that does candidate tracking, and then you get safe web application that runs on top of it. So this is particularly advantageous, but since we are doing candidate tracking for almost all string variables in the program, there is a considerable overhead for that, and it can be minimized by propagating candidate strings which depend on user input, and that's what we are currently doing. So there is some more recent work, basically mostly related to dynamic techniques and static techniques for prevention of SQL injection attacks. First of all, the most common defense employed is input validation, but it is kind of well known that these are not robust against different formats of strings. So for instance, if the backend uses alternate encodings, the attacker will be able to inject SQL commands into user inputs that make use of these encodings, and this may slip through the input validation function. And mostly programmers, there are lots of bulletin board forums which describe how these input validation routines can go wrong. So the notion of comparing parse trees is a much more robust notion for defending SQL injection attacks. So there are static analysis techniques that that solve a slightly different problem. They are used for merely identifying which user inputs reach a SQL query without being validated. So that's the objective of static analysis techniques. So they are merely used to identify vulnerable applications, vulnerable locations in an application. They do not offer, so for instance, if an application does input validation, they do not offer any assistance to check the soundness of the sanitizing routines. And another recent work involves use of static analysis to build query structures and use that for dynamically preventing attacks. So you can guess the structure using static analysis at each query issue location, and then at runtime you can see whether the query received matches any of the queries that you learned by static analysis. And we've shown in the paper that this is not robust when the query depends on predicates over the input, because it loses track of control flow. So there are other dynamic techniques that people have worked on. So primarily it involves information flow tainting. So you taint user inputs as it enters the program, and then you see whether the tainted input contributes to SQL query structure. And these we believe are the best defenses for SQL injection. We also have a very detailed comparison. So for instance, when you have a third-party function for which you don't have access to, using a tainting mechanism, you should assume that, for instance, all the result that comes back from the third-party function is all tainted, and so this may generate false positives. But using CANDID, if the function doesn't have side effects, you can make calls to the function twice. You just supply the candidate string once and the actual string once, and then you get back the results and compute the candidate query. So there are several detailed comparisons that are shown in our paper. And so the contributions of this talk are primarily a technique to defend SQL injection attacks by guessing or deducing the programmer intended query structures at runtime, and it's resilient to different scenarios that might occur in real code. And we did several experiments on real code, and all attacks were defended, and there were 0 false positives. And and the message that we want to give at the end of this talk is that dynamic techniques are best suited for defending SQL injection attacks.
Time for a question?
I'm early.
Yes.
We got a lot of time.
So, your approach works for Java. So if you want to use your approach for other programs,
It shouldn't matter. The language shouldn't matter at all, because the transformation is extremely simple as long as you can implement this. So the JVM approach works for applications written in Java, JSP, and so on. But if you the transformation itself is not complicated. It's just replicating or shadowing the operations done on real variables. You can even use some kind of textual parser to implement the transformation. That's probably what's needed, nothing more, because all it requires is initializing the candidate variables and then replicating the operations done on real variables and candidate variables. So it should be fairly easy to implement on any programming language, provided you want to do the source transformation. So does it address your question?
So could you go to the slide where you have 3 usernames and then separated by space? Mm-hmm. So I think the effectiveness depends on the string operation. So suppose I have a function which returns the substring ended at the first space, and then I issue that call, and then I get the first substring, and then the second call is I get the next portion that are from the first space and the second space. Mm-hmm. So then if the string is here, then the first call will get John, the second call will get Jane, and the third will get Mary. But if I issue it on this input, the first will be all A, the second will be empty string.
So it depends on where you implement the transfer. So are you doing the call to that function? So are you looking at where the space is in the code, and then you are making a call to return?
So if the function get an integer index and then get a substring, so this would work. Mm-hmm. But if the function, the library call directly return a substring, start from the beginning, ending at the first space. So because it's a string operation, I guess you would issue the same call on the string method and then.
But as I see it, the logic of the original application is now put in this third-party library function. Is that what you're saying? So now the library function will have to do the same thing. It has to search for the string based on, it has an integer value, and then it computes a substring. Right?
So this is really, for example, in Java, they probably, I don't remember the string API, they probably do not have this function. So you're going to kind of change the Java library function source as well if it's implemented?
So we are doing it at the bytecode level. So for instance, we can transform everything that is available in bytecode form.
So then it will work at the JVM level, but if you do source transformation, then that may not work.
So in that we are assuming here that the source for that library function is also available if you're doing
it. Okay, so you are also.
But our primary implementation is on bytecode, so it will work on everything. Okay. So it depends on how deep you can go into the implementation of the functions. Mm-hmm. So at some level, if there is a call, and if the call has if the source for that is not available, then yeah. But then you can do this bytecode transformation and.
But then for other languages
all library functions in Java have this property that the length of the string, we have this notion of length preserving the paper. Mm-hmm. So almost all functions in Java are length preserving, which means that all our transformation is sound for all the functions in Java API. But I am sure you can create a situation using a third party function, right, which has a side effect as in this case it depends on some value which is not available to CANDID, in which case the real and the candidate strings may differ, right? But we have not encountered such a function in the actual examples that we have tested, and we believe that if given access to all the sources, our transformation will work. Yes.
I could be wrong, but I think in Java strings are constant. That when you create a string, you can't change it without changing what the reference is.
No, but I don't.
So you wouldn't worry about the length changing of the string because.
No, but it's not just a string. I mean, you compute a string from another string. So you take a string and do a substring, and you compute another string. So you need to create a candidate string for this new string that's being constructed, and so even though strings are not manipulated directly, you can do string operations and get new strings as a result of those operations. So in which case you have to create these candidate strings.
Thanks.